Now we will study the cooling system which are employed in the IC engine for cooling the engine system. So first we see the introductory part of the cooling system. As we know that fuel is burned inside the cylinder of an internal combustion engine to produce power. We know that during the power stroke, the fuel is burned and hot gases is produced, and due of which the temperature inside the cylinder as well as in the engine block will rise, and it is necessary to drop down the temperature for protecting the engine against the failure due to temperature. So the temperature produced on the power stroke of an engine can be as high as 1600 degrees Celsius, and this is greater than melting point of the engine parts, means it is too high temperature. So at that temperature, if we do not reduce the temperature, then it may cause the melting of the engine parts. So it is quite necessary to drop down to the temperature of the engine system. For example, melting point of the cast iron is 1100 degrees Celsius and of the steel is 1450 degrees Celsius, and that of the aluminum alloy is 660 degrees Celsius. So these all are below the 1600 degrees Celsius. So we have to drop down this temperature, this high temperature 1600 degrees Celsius as per the types of engine and metals we have used. If we have used aluminum alloy, then we must bring down this 1600 temperature below 660 degree. Otherwise, the parts which have been made through the use of aluminum alloy will melt and engine become failure. The cylinder and cylinder head are usually made of cast iron, and piston in most cases are made of aluminum alloy. Means different parts of the engine we have studied that they are made with the different types of metal. Now cylinder and cylinder head are made of the cast iron, so it can withstand up to below, we can say 1100 degrees Celsius, and piston is generally made of aluminum alloy, so the temperature must remain below 660 degrees Celsius, otherwise piston will melt and our system will fail. So this is the cause why we have to cool the engine system. It is estimated that about 40% of the total heat produced is passed to the atmosphere via the exhaust. Means during the exhaust stroke, whatever energy that has been produced by the burning of fuel in the power stroke, 40% of that energy goes out with the exhaust gases in the atmosphere. So we have now 60% energy within the engine system. Out of this, 30% is removed by cooling system. Means we have to remove 30% of this energy remaining in the engine cylinder by cooling the engine system. Either it may be cooled down around the circulation of the water around the cylinder, or around the space that has been provided in the cylinder block. Only 30% is used to produce useful work. Means from the total energy that has been produced by burning of the fuel, only 30% energy is, we can say, produce useful work. So 30% energy is utilized to produce the useful work. Either that useful work may be transporting our tractor from one place to another, or to cool the implement or instrument, or a particular agriculture operation. So we are losing 70% of the heat that has been produced by the burning of fuel, either by removing it in the atmosphere during the exhaust stroke, or by removing it with the cooling system by applying cooling system in the engine. Now, bad effect of high temperature in the engine. If the temperature of the engine is too high, or we can say we have not used any cooling system, then what will be the bad effect to the engine by the high temperature? First, cylinder and piston may expand to such an extent that the piston would seize in the cylinder and stop the engine. As we know that as and when the metal gets heated, its temperature rises, and due to the rise of temperature, the metal expands. So, in our case, if piston get heated due to the high temperature created by the burning of fuel in the power stroke or by the burning of the fuel, then it gets heat and it may expand. So, it is necessary to drop down the temperature of the piston at certain degree so that its expansion will not be too much, and if it expand more, then it may cause close contact with the cylinder and it may seize in the cylinder, and due of which engine will stop. Now second, lubricating quality of the oil inside the cylinder would be dropped or destroyed due to the high temperature, and there may not be sucking of air in the cylinder. Means we know that due to the high temperature, the lubricant oil which has been used to lubricate different parts of the engine may lose its viscosity, may lose its lubricating characteristic. So due of which there may not be sufficient lubricating property in between piston and cylinder system, and due of which cylinder may not suck the air, because there may be air leakage in between cylinder and piston due to loose or destroyed quality of the lubricant oil. Now third, pre-ignition of fuel mixture would take place and would cause engine knocking as well as loss of power. We will see what is knocking. Knocking is nothing but it is undesirable noise that comes out due to the improper burning of the fuel and certain many other reasons. That is called the knocking, or we can say undesirable sound that has been produced within the engine system is called knocking. Due to pre-ignition of the fuel mixture, in case of if the temperature of the combustion chamber is high, then there will be knocking of the engine system, and due of which we will lose the engine power. For satisfactory performance of the engine, neither overheating nor overcooling is desirable. Means if we want to achieve optimum power from the engine, then our engine system must be set at proper temperature. It should not be overheated or it should not be overcooled. If these both extreme condition may be there, then there will be loss of power in the engine system. Experiments have shown that best operating temperature of IC engine lies 140 degree Fahrenheit to 200 degree Fahrenheit depending upon types of engine and load condition. Means during the research on the IC engine, it has been found that the best temperature for the optimum operating system or optimum power gain should be 140 degree Fahrenheit to 200 degree Fahrenheit depending upon the types of engine and engine that has been used for how much load. If the engine is used for more load, then maybe temperature of the engine will be near to 200 degree Fahrenheit. So this is the, we can say, bad effect of the temperature on the engine system. Now purpose of cooling. What is the main purpose for cooling the engine system? First, to maintain optimum temperature of the engine for efficient operation under cold condition. Means if our engine system is ideally running without load, or it may be running with different types of load, either medium or high load. In that condition, the temperature of the engine may be different. If it is running without load or without much load, then in that condition engine may not have obtained more temperature. But if it is loaded with high load, or we can say it is operated with high load, then it may gain more temperature. So it is necessary to maintain optimum temperature which has been recommended for a particular type of engine for its efficient operation. Then second, to dissipate surplus heat for protection of engine components like cylinder head, piston rings and valves. We know that during the power stroke, combustion of the fuel produce the high amount of heat, and if this heat is not removed with the cooling system, then there may be surplus heat in the cylinder piston system, or we can say our engine. So certain parts that are in the close contact with this heat of combustion are cylinder head, piston rings and valves, and these parts may damage due to surplus heat developed and added each and every cycle of the engine system. So we must dissipate or we must remove surplus heat from the engine. Now third, to maintain the lubricant property of the oil inside the engine cylinder for normal functioning of the engine. As we know that if the temperature of the system become to go up to highest range, then it will damage the property of the lubricant, or it may decrease the lubricant quality of our lubricant oil. The viscosity of the lubricant oil drop down, and in that case it loses its strength to lubricate the engine parts. So if it is not doing its function of lubricating the different parts, then engine may get damaged. Piston may seize in the cylinder. There may be friction in between rotating parts. So in this way it affects the normal functioning of the engine. Now there are two different methods of cooling of the IC engine. First is air cooling and second is water cooling. Now we will see first air cooling. In the air cooling, the air cooled engines, those engines in which heat is conducted from the working components of the engine to the atmosphere directly. Means in the air cooled engine, whatever excess heat or we can say surplus heat that has been produced within the engine system, that is removed from the working components directly in the atmosphere by first pulling the atmospheric air on the hot parts of the engine that are projected in the atmosphere. So here we are not circulating air inside the engine, but on the periphery or in the circumference of the engine parts which are heated, airflow is produced, and that removes the surplus heat from the engine. Now in such engines, means in the we can say air cooled engines, cylinders are generally not grouped in a block. Means we know that if our engine is 4-cylinder, 4-stroke, then in that case 4 cylinders are embedded in the cylinder block. But in this case we cannot use air cooling system. So for use air cooling system is employed in the engines where cylinders are not grouped in a block. It is separated from each other. It may be in the V fashion or in the F fashion, but it is separate and it is individual, not grouped in a block. Now principle of air cooling. The cylinder of an air cooled engine has fins to increase the area of contact of air for speedy recovery of the cooling system. Cooling system. What is fins that we will see in the figure. See, this is our cylinder. Inside the cylinder our piston rotates, but the circumference or outer surface of the cylinder has projected parts that is called the fins. This is the fins. It is employed to increase the total surface area of the cylinder which are in the open atmosphere, or we can say it is in the ambient environment. So to increase the total surface area of the cylinder for speedy removal of the heat, the surface area of the cylinder, circumferential surface area of the cylinder is maintained as a projected fins over the periphery of the cylinder. So the cylinders of an air-cooled engine has fins to increase the area of contact of air for speedy cooling. The cylinder is normally enclosed in a sheet metal casing called crowning. See, this is the crown of the Vespa T5. So this covers the cylinder and air is introduced from this hole for efficient cooling of the engine system or cylinder. See, in this figure you can see the outer periphery or outer surface of the cylinder which have fins. We know that on the upper parts, generally in the clearance volume, our fuel is burned. So in that area there will be high temperature. So here longer fins were employed for greater, as they produce greater heat and it may be removed. So these fins are of, we can say, longer side. For improving the cooling, we employ here the longer side fins. Here normal side fins are used because this portion is far away from our combustion chamber, so temperature will not be much more. Here mostly this portion will have maximum temperature during the burning of the fuel. So here bigger size fins are employed. As and when the cooling starts, the direction of the airflow from outside the engine by, we can say, flywheel that has been projected over the crankshaft of the engine rotates the flywheel and that produces the air current, and that air current passes through around the, we can say, engine cylinder which has employed with the fins. So the cooling fins are used to increase the surface area export to the air system. See, in our two-wheeler, generally in the bike, you have seen such type of fins that are employed for, we can say, efficient cooling to increase the surface area of the cylinder for efficient removal of the excess heat from the system. The flywheel has plates, means as I have told that see, this is the flywheel, and on the upper periphery of the flywheel this type of fin are developed. So the flywheel has plates projecting from its face so that it acts like a fan drawing air through a hole in the crown. See, this is the this crown is employed over this flywheel. So due to the rotation of the flywheel, due to the arrangement of these fins, it sucks the air, and it sucks the air through this hole, crawling hole provided in the crawling, and directed it around the finned cylinder. Means this whole air is directed to cool the fins that has been employed around the cylinder. This is the cylinder crawling of the Vespa T5. Now, for maintenance of air cooling system, passage of air is kept clean by removing grasses etc. Means either there will be blockage of this hole or blockage in the fan system, then we have to remove these materials from this hole as well as from these pins for the effectively entering of the airflow current inside this crawling parts. This is done by removing the crawling and cleaning out the dirt etc. by a stiff brush or compressed air. Means first we have to remove this crawling, and after removing whatever dust or anything that has been stick or adhere with this either this pin or inside of this crawling, that may be removed through stiff brush or either compressed airflow is passed inside the fins as well as in the crawling, and it may be washed out anything that has been adhered with this system. When separate fan is provided, the belt tension is to be checked and adjusted if necessary. If means if this flywheel has not that projected part and separate we can say pin is provided for efficient entry of the air, then in that case the tension of the belt should be proper, otherwise it will not rotate or effectively and it will not suck the air inside these traveling parts. This is the thermostat which sense the temperature, and according to this it operates the system for efficient cooling. Now, advantage of air cooling system or air cooling engine. Certain advantages of air cooling systems are there. It is more simple in design and construction. Means there is no extra parts in this system, so it is very simple in construction and as well as in the design is also simple. Here water jackets, radiators, water pump, thermostat, pipes, holes, etc. are not needed. Means in the air cooling system only we are employing certain thin system on the flywheel and also using crawling around the we can say our cylinder. So there is no need of water jackets, radiators, water pumps, thermostat arrangement or pipes, hole, etc. in this system. Now it is more compact. Means in this there are less parts, so it is more compact. It requires very few space for its fitting in the engine. It is comparatively light in weight, means no more parts, so its weight will be much lighter as compared to the water cooling system. Now some disadvantages. First, there is a uneven cooling of the engine parts. Whatever parts is just near the fin system or near the fins of the flywheel, then it cools more, and the either side or we can say opposite side will cool less. So there will be uneven cooling of the engine parts. Second, engine temperature is generally high during the working period. Means it will not cool down the engine much greater way. So in that case, generally cooling is slow. So generally during the working condition, there will be no much more reduction of the temperature of the engine system. So temperature of the engine will remain little high as compared to the water cooling system. Now second, we see the water cooling system. Water cooling, in the water cooling system, engine using water as a cooling medium is called the water cooling engine. Means in the air cooling system, we employ the air flow current for we can say cool down the different parts of the engine which are at a higher range of temperature. So, but in case of water cooling system, we are using water as a medium to cool down the engine. The liquid is circulated round the cylinder to absorb heat from the cylinder wall. Means outer side of the cylinder wall is make direct contact with the water circulation. So the heat that has been generated inside the cylinder is conducted through the wall of the cylinder to the water, and water absorbs excess heat from the cylinder and then it runs towards the radiator. We will see the water cooling system of the engine. At that time you will see the different parts of this water cooling system. In general, water is used as a cooling liquid. Means mostly water is used as a cooling liquid, but in the cold region where temperature is too low and there may be chance of we can say freezing of water. In that case, certain coolant are used in the cooling system which remain in the liquid form during the low temperature. So mostly cooling liquid is water, but in certain cases if the region that has been frequently go beyond the 0 degree Celsius temperature, or we can say in the temperature range of minus, then in that case water may get in the form of ice. So at that time certain special coolants are used which remain in the liquid form below 0 degree Celsius, or we can say in the minus degree temperature. The heated water is conducted through a radiator which helps in cooling water. Means whatever water it has been heated up through the circulation inside the cylinder probe, then it goes to the radiator, and in the radiator further cool down, and then cooled water is again circulated in the engine system. We will see detail in the cooling system. There are three common methods of water cooling. Means water cooling methods are of three types. First is open jacket or hopper method. Second is thermosiphon method, and third is forced circulation method. These are the three methods generally employed for engine cooling using the water as a substance. So first is open jacket or hopper method, second is thermosiphon method, and third is water circulation method. This is the water cooling method which employs radiator system that we have seen. Third method, that is forced circulation method. From the figure we can see this mechanism of this water cooling method, forced circulation method. See, in this is our cylinder piston system which are fitted in the engine block. First, second, third, fourth, means 4-cylinder 4-stroke engine is there. In this, we know that during the burning of fuel in the end of the compression stroke and at the time of power stroke, excess heat is generated. That increased temperature of the cylinder is piston as well as total cylinder probe and the head as well as we can say engine block. So see, this is water channel in the block and head. See, this is the water channel around the cylinder. Each and every cylinder there is a water channel through which water is circulated on the periphery of the cylinder. So this is the channels inside which water is circulated around the cylinder. See, from here we can say cool water or cold water enter in the engine system, and due to the absorption of heat from the engine system or around the cylinder, hot cylinder, it get lighter and then it rises up, and then from this it goes to the upper parts of the radiator. Here top tank is given in which we fill the water. See, first we see the different parts of the this water cooling system. See, water channels in the blocks and in head. See, these are the water channels inside the engine block as well as we can say on the head of the cylinder. Then thermostat valve open or close. This is the thermostat valve. According to the temperature set, it opens or close, and it passes the hot water from the top of the we can say cylinder head to the upper tank of the radiator. So as and when suppose we have set this valve for the we can say 170 degree Fahrenheit temperature, then as and when the water of, that has been comes out from the head of the cylinder head of the engine that gains the 180 degree Fahrenheit temperature, then this valve opens and the hot water goes in the radiator. Then coolant filling plug means from the air we can fill the water in the upper tank. This is the top tank in which we can generally fill water as a coolant, or maybe in the cold region, as I have told that instead of water certain coolants are used. This is the expansion tank and cap, means due to the high temperature there may be water vapor, so there may be expansion of the volume. So in that case this expansion tank is employed to accommodate the water vapor as well as that volume that has been increased due to the high temperature. Then this top radiator hose, this is the top radiator hose which conducts the hot water from the engine head to the upper parts of the radiator. Then this is the radiator core. This radiator core is in such a way that as and when the fan starts, then it sucks the water through the radiator core. So, and in the radiator core, water is circulated to cool down. So, radiator core are maybe we can say a tubing system in such a way that water circulate inside and air current flows on the periphery of these tubes that in which water is circulated. So this is the radiator core. Then this is the bottom tank from which whatever water that has been circulated from this radiator core is collected, and then it cold water is then again circulated at the bottom part of the engine to absorb the heat that has been produced during the power stroke of the engine. So this is the we can say circulation of the water for this certain extra parts. See this engine driven fan. This engine driven fan means from this crankshaft certain arrangement is made to run these fans. See here belt and pulley arrangement is there to run the this engine this fan by the power of engine. So this fan runs and it sucks the air from the radiator core. Then water pump. This is the water pump which we can say sucks the water from the radiator. Then bottom radiator hose. This is the bottom radiator hose. In some cases during the winter, if the engine is too cool, in that case this heater facility is provided, in which the heat is generated through the electric heater, and that has been supplied to the engine system to rise the temperature and to easy start of the engine during the winter season or cold season. So this is the water cooling system. You can see here how it works. Suppose we know that due to the burning of the fuel, there will be high temperature at the, we can say, top part, or we can say in the clearance volume of the cylinder, and that spread around the cylinder as well as in the engine block. So whatever cold water that enters in the circulating parts of the engine block, that circulates around the cylinders, the hollow parts of the cylinder, and it flows around the cylinder, and then it gains the temperature, so it becomes lighter and go upward, and then hot water goes here. This is the thermostat valve which regulates the water flow. If the hot water gets temperature at above certain set temperature, then this valve open and it allows to pass water for cooling in the radiator. This is the radiator core in which water circulates, and this fan is driven by the engine power, sucks the air, and air current flows across the, we can say, our radiator, and it cools the water which is circulating inside the radiator. Then due to the removal of the heat by the air current or air flow, cold water comes at the bottom, and then it again circulated in the engine. So this is the water cooling system. As we have seen all these parts that has been employed in the water cooling system. So we will not go much more in detail. Now another system that has been employed, that is water jacket method. In this method, generally this is our cylinder piston assembly. Around these water jackets are provided. See, on the either side of the cylinder there are two water jackets, and through this water jacket coolant is introduced from the bottom and then it circulate inside the porous space of the water jacket and then it goes out from the top and then again it may come in the bottom and thus it is circulated in the circulation fashion. This is the water jacket method. Then this is the hopper method. Generally in our diesel engine the hopper is provided at the top of the engine head and in which cold water is employed and this water absorbs the heat of the engine system. So this is the hopper method. Generally when engine is not of much HP, means it is not generating more power, then in that case this hopper system may be employed. Then this is the thermosiphon cooling method. In thermosiphon cooling method we know that if the rise, there will be the rise of temperature of either any fluid, that fluid may be either gas or water, then it will rise and the water or air which has higher density or we can say which has less temperature have more density, so it will sit down at the bottom. So there will be natural flow from the, we can say, bottom to top. See here, this is the radiator for filling the water or coolant we have kept. So if we fill up the radiator with our coolant through the upper tank, then as and when the water which is cold will enter in the engine system and it gains the heat, then it become lighter and then it goes on the upper portion of this circulating system and then goes in the upper parts of the radiator. From in this radiator through the fan we remove the heat, so heat is removed from our water or coolant and then it become cold and become heavy, so it goes in the bottom and again it is circulated in the engine system. So this is done in the, we can say, simply thermosiphon system. We are not employing any say pump for pressurizing the circulating water or liquid. So it is called the thermosiphon cooling system. Here we are not applying force. Only thermosiphon effect is used for circulating the coolant inside the cylinder or around the cylinder or around the engine block. So this is the thermosiphon cooling method. Now we will see the ignition methods. We know that in the 4-stroke diesel engine, or we can say compression ignition engine, there is no need of spark plug to ignite the fuel. In this system, in our diesel engine, or we can say in our compression engine, due to the heat of compression, there will be high temperature of the compressed air, and this compressed air will ignite the fuel that has been introduced through the atomizer in the cylinder. So there is no need of spark plug or any ignition system in the compression ignition type of engine. But in case of 2-stroke engine or our petrol engine, we are introducing air fuel mixture inside the cylinder and there is no much high temperature of the air fuel mixture after the compression of this. So in this spark ignition engine, there is a provision of spark plug which produce spark and ignite the air fuel mixture inside our engine system. So we will see the ignition system that may be employed in the spark ignition engine. Fuel mixture of IC engine must be ignited in the engine cylinder at proper time for useful work. Either in the, we can say, our petrol engine, or we can say our diesel engine, or we can say our 2-stroke or 4-stroke engine. We must ignite our air fuel mixture at proper time for producing useful work. Arrangement of different components for providing such ignition at proper time in the engine cylinder is called ignition system. Means if we have employed any system which acts as a ignition system to ignite the fuel at a proper time inside the cylinder, then this system is called the ignition system. There are 4 different types of igniting fuel. Means in 4 different fashion we can ignite the fuel inside the cylinder at proper time for producing the power. First, or we can say A, ignition by electric spark. That we can say is a spark ignition system. Then second, or we can say B, ignition by heat of compression. That is compression ignition. In case of our 4-stroke diesel engine, this compression ignition is the system which directly ignite the fuel that has been injected through the injector at proper time at the end of the compression stroke, and due to the hot air that has been compressed, that ignites the fuel that has been injected through the injector. Then C, third, ignition by hot tube or hot bulb. And fourth, or D, ignition by open flame. Only first two, that is we can say spark ignition as well as compression ignition, both are the important methods in the modern engine system. C and D are not employed generally in the modern era. Now first we see the spark ignition. The purpose of spark ignition is to deliver a perfectly timed surge of electricity across an open spark plug cap to each cylinder at the exact moment so that the charge may start burning with the maximum efficiency. We know that in the spark ignition system, air fuel mixture is introduced during forward stroke, and the temperature of this air fuel mixture is not too high, so it will not ignite on its own. So we have to employ certain system that can ignite them. So for that a spark plug is used, and at the tip or at the tip point of the spark plug there is a certain gap. So in this gap a surge of spark, a flame of spark is produced, and that goes in the clearance volume of the cylinder and ignite the air fuel mixture that has been presented in the clearance volume of our engine. So in this way we start burning our fuel in the spark ignition engine. There are 2 methods in spark ignition. Means spark ignitions are of the 2 types, or 2 methodology are used to ignite the air fuel mixture using the spark ignition. First is battery ignition and second is magneto ignition. These 2 methods, battery ignition method as well as second is magneto ignition method, are employed. In the battery ignition system we can say battery ignition system includes 2 circuits: low voltage, that is primary circuit, and high voltage, that is secondary circuit. In the low voltage circuits, it is consist of battery, ignition switch, a series of resistor, primary winding, and contact breaker. All are connected in the series. These all parts are connected in the series. In the high voltage circuit system, it is consist of secondary winding, distributed rotor, high voltage wiring, and spark plug. And same way in the primary circuit, all these parts are connected in the series in the high voltage circuit system. See, this is the figure in which primary circuit is given different components. This is see battery, then distributor points, then primary coil, then this is blast resistor, ignition switch, and ignition coil is there. That all are connected in the series. See, you say this is the series. The primary circuit consists of low voltage wiring and components. Use conventional types of automotive primary wires. Controls when ignition will take place when oil fires. This is the ignition circuit we can say battery ignition system in which primary circuit as well as secondary circuits are employed. We will not go much detail. This is the battery ignition system in which the battery is employed for giving the power to the system. From the battery power, it goes to the ignition coil and then different parts for storing the power. Capacitor is used to store certain power, so it may operate the contact breakers, and then this system produce the current that flows in the circuit and goes to the distributor, and from the distributor the spark is delivered to the different plugs of the engines. See, if our engine is four cylinder two-stroke engine, then in that case there will be four cylinder. So for each and every cylinder there may be separate spark plug, and to control the distribution of spark, distributors is employed in the system. We will not go in the much detail in this system. Now this is the magneto ignition system. Magnets are used in the circuit to produce the electric current, and this electric current produce the spark, and it is distributed in different spark plug of the different cylinder system. Now we are using generally batteries in the system, so care and maintenance of the battery, how we can take care and maintenance of the battery. Specific gravity of the electrode should be checked at suitable interval. If the specific gravity is below 1.225, then it should be charged. Means if the fluid inside the battery or chemicals inside the battery has a specific gravity less than 1.225, then it may be taken for charging. Level of the electrode should be checked in the battery. The level should be about 12 to 15 mm above the battery plates. If it is not so, distilled water should be added in the battery. We have to maintain water level, or we can say level of our chemicals 12 to 14 mm above the battery plate. If it is not above the 12 to 15 mm above the battery plate, then distilled water is added, and the level should be kept 12 to 14 mm above the plates. The top of the battery should be kept clean and dry. Means the upper portion of the battery system where different connection points are there, that should be kept clean and dry to prevent its short circuiting or leakage of the charges, etc. Over tightening the clamps and terminals should be avoided. Means we are taking different terminals from the battery for taking the power. So in that case, the clamps and terminals should not be over tightened. Battery terminals should be cleaned frequently. Means on the upper surface of the battery there are different terminals to take out the power. So these terminals should be kept clean, and it should cleaned frequently to avoid any further damage. Overcharging of the battery should be avoided. Means we should not overcharge the battery. If it is overcharged, then it may damage the inside part of the battery system. Now cause of ignition failure in the battery system. Means how battery can fail, what is the reason, different reason due of which battery system fails. First, breaker points not properly set. Means in the battery ignition system, if the breaker points are not set properly, then the ignition system will fail. Battery discharge or defective dynamo. Means if the battery is discharged or the charging, the dynamo is defective. Defective condenser. If there is something defect in the condenser, then spark plugs broken. If the spark plug is broken, the tips of the spark plug is broken, then there will be no charge carried out from top to the inside the cylinder. Timing setup is not done properly. The timing charge that has been delivered at proper time after the end of the compression stroke, when it should be delivered, should be set properly. Distributor bearing or sharp worn or sharp bent. Means some defect in the distributor bearing, or there may be burning of staff or shaft may be bent. In that case, there may be failure of battery ignition system. Spark plugs of the wrong heat range used means proper spark plug is not used for a particular engine system. So in that case, according to the heat that has been generated during the power stroke, or it is necessary to use spark plug for a particular type of fuel. So if the heat range that has been marked for the spark plug should be matched with the fuel